So going through our 5-number summary, to the best of your ability, let's identify the minimum. What is the minimum? 2. What is the lower quartile? 4. Median? 6. Upper quartile? 8. And maximum? 10. Remember, here's our minimum. So we're reading this box and whisker plot. The ends of the whiskers are the minimum and maximum. Right in the center of the rectangle is the median. The left edge, the smaller side of the rectangle, is the lower quartile, and over with the larger numbers, the other end of the rectangle is the upper quartile. Is there an outlier in this data?
No.
No. What would we be looking for if there was an outlier?
An extreme difference.
The maximum or minimum.
Maximum, what would we notice about the maximum or minimum?
It's super far from the box.
It'd be very far away from the rectangle. So something like the rectangle's over here, and the maximum is over here. Or the rectangle's on this side, and the minimum is way over here. That's what an outlier would look like. If it's just stretched a little bit one way or the other, use your judgment. If it's stretched very far from the rectangle, that's an indication of an outlier. So since there is no outlier, what is the best measure of center for this situation? The mean. If there had been an outlier, what would the best measure be? Median. So I've got a funny today that has to do with our mean and median. It's only so amusing, but it's math jokes. I have to get my kicks. All right. I want you guys to go to page 300. And up at the top of the page, question number 6, we're going to use that space to answer this question, which is not the same thing as what's printed on your page. All right, I'm going to give you guys a moment or two to write down this question instead of what's printed on the page there. All right, who remembers what the IQR is? Not divided, but subtracted, yes. The IQR is the interquartile range. The interquartile range. This is the difference of the upper quartile and the lower quartile. What does it measure? It measures how spread out the middle half, or the middle 50% of the data is. This helps me not only understand, so the median and the mean help me understand what's expected or typical, that measure of center. The interquartile range is telling me how far out on either side of that is still not surprising. Might be a little lower, might be a little higher, but you know, when I go and look at a group of kindergartners, they're all going to be different heights. But I can make a bet that there's probably not very many kindergartners that are as tall as me. That would be highly unexpected. But there's going to be a range in there that's normal or typical. That's what our interquartile range is helping us to measure. Taking like the half of the kids that aren't the shortest kids, they're not the tallest kids, I got the kids right in the middle. How spread out are their heights? Standard deviation. Standard deviation is similar to the interquartile range, but standard deviation is how spread out from the mean the average a typical data point is. If it's more spread out, the standard deviation is bigger. If it is less spread out, the standard deviation is smaller. Running out of room here. A lot of times we'll talk about standard deviation when we talk about normal curves or bell-shaped curves. Have you guys ever seen like a bell-shaped curve? Looks, you're gonna laugh at my art skills here, but it looks something like this. Does that look familiar at all? The mean on a bell-shaped curve is right in the center, and there are 3 standard deviations on either side. I'm going to abbreviate standard deviation because that's a very long word. So this is one standard deviation from the mean to one side. Most of the time when we talk about standard deviation, we look on either side of the mean because we want to be equally balanced on both sides. So the farther out that I have to measure on my number line to get to that first standard deviation, that's what determines how, like, the number that I'm using for that. So we would plot all of our data points on a number line. Similar to what you see in your book, there's dot plots there. And then we're going to say, like, well, how far over from the center, how far over would I have to go on either side of the mean of the center to capture about 2/3 of all this data? Because that's what my standard deviation is going to do. Speaking of, let's look down at those graphs. We want to put these in order. I don't know why they gave the boxes without any labels, like they expect you to redraw them. Are you guys okay if we give our graphs names? So then we can order those in the boxes below. All right, so let's call this first graph graph A. Let's call this one graph B. And let's call this one graph C. It does not matter where on the number line the graph is. We're not looking at the numbers along the bottom. We want to know which one is the least spread out. B. So that's what I would put over here. Graph B is the least spread out. It does not matter at all that it's sitting over there on the negative numbers. What I'm looking for is it is not very wide. If I'm putting them in order from least to greatest, if I'm putting them in order from least to greatest, we said B was the least spread out. Which one do you think would go in the middle? It's not the most spread out, but it's not as narrow as B. A. And so by default, that leaves which one as the greatest standard deviation? C. This one is the widest along the bottom. All right. Go ahead and flip the page for me. We're going to change the wording just a little bit up at the top. What's on your page is how do outliers impact the mean absolute deviation. We have not talked about that, and we're not going to. I want you to change that to interquartile range. So where it says mean absolute deviation, I want you to cross that out and write interquartile range. That's the only thing that we need to change about this question. How much did outliers affect the median? When we looked at that yesterday, the median, when we cross out and go to the middle, did outliers have a big impact on that? No? It was a big impact on which one? The mean, when you add and divide. Because if we have a very, very big number that gets added, that's going to impact it. If we just tack a very, very big number onto the end and we cross out and go to the middle, it doesn't shift where the center is very much. So with the IQR, outliers do not impact this much. They don't shift the middle, median, or the upper and lower quartiles hardly at all. Standard deviation, though. Standard deviation is based on the mean. Which measure of center did we say was very affected by outliers? The mean. So if the mean is very affected by outliers and standard deviation is based on the mean, do you think outliers do or do not have a big impact here? They do. Outliers have a big impact on the mean. And so they also have a big impact on the standard deviation. So if my data has an outlier, what should I use to measure the center? What's the best measure for center if I do have an outlier? The median. What's the best way to measure how spread out my data is if I do have an outlier? What's the best way to measure how spread out my data is if I have an outlier in my data? The interquartile range. If I don't have an outlier in my data, what's the best way to measure what's typical? If I do not have an outlier, what's the best way to measure what's typical? If there is no outlier. Standard deviation and the mean. Standard deviation to measure how spread out it is. Mean to measure what's typical or expected. All right. So I want to look at this data set that we had yesterday. Did this data set have an outlier? Yes. Which one is the outlier? 20 is our outlier. So with the outlier, bless you.
Thank you.
The best measure of center would be what? If I have an outlier, what did we say our best measure of center was? The median. And if we're going to use the median as our measure of center, because we have an outlier, what should we use as our measure of spread? The IQR. All right. What about without the outlier? Yes. We're going to use the mean as our best measure of center. And what should we use as the best measure of spread if there is no outlier? I'm sorry, I didn't hear what you said. Standard deviation, yes. I want you guys to look at the 3 graphical representations that are on page 302. And based on what you see, I want you to tell me what you think the best measure of center is, the best measure of spread, and why you believe that. I'm going to give you guys about 3 minutes to work on this on your own. 3 graphs, so a minute per graph. Based on what you see in that visual representation, what do you feel the best measure of center is? What do you feel the best measure of spread is? And why? On the top graph, that bar chart, it's called a histogram. When we have a bar chart like that and all the bars are smashed together, it's called a histogram. What's our best measure of center there?
Median.
Median. And so since we went with the median as our best measure of center, that means we should use what as our measure of spread? IQR. Tell me why you guys picked the median and the IQR for this data. Because it has an outlier. On a histogram, we can see our outlier as this little piece of data over here that's far away from the rest of the data. All the other data is in those other bars. This one's off by itself. What about that dot plot right in the middle? What should we use as our measure of center? Yes. Just go ahead and go. You'll be fine.
Mean.
We should use the mean here. So what should we use to measure how spread out it is? Standard deviation. Why? I'm sorry, one more time, just a little louder. Yep. There are no outliers. The data is clustered together. All right, last one. Box plot, something that we've worked with a little bit more. What should we use as our measure of center? Median. And because we picked median, that means we should go with what as our measure of spread? IQR, interquartile range. And why? Because it has an outlier. Where is the outlier? 8. Yep. I just realized that I misspelled because. Needs a U in there. This data also has an outlier. Turns out on both of these graphs, the first one and the last one with outliers, they are large outliers because they happen over in the larger numbers. But we could have small outliers too. They would still greatly impact the data. A small outlier doesn't mean a small impact. It just means that it's a very small number and all the rest of the numbers are larger. A large outlier means that most of our data is smaller numbers, and then we have this one very big number here. All right. That is all I have for you guys today. Couple things quickly to wrap us up. You guys have some class time right now. That last homework assignment, descriptive statistics, is due tomorrow morning. Tomorrow at the beginning of class, I will pass out the sheet that you will get to use on the final exam. It'll be just like most of the previous tests that we had. Not Unit 12, where all we had was the index card. This will be like the other ones, where you get one side of a standard sheet of paper. You can put whatever you would like to on there. We're going to start reviewing unit by unit beginning tomorrow. The final exam will not have things organized unit by unit, but going unit by unit to review seems to be the most straightforward way to help us recall and remember things. Anything that you're like, I don't think I'll remember that come time for the exam, those are the types of things that you should make sure to put on your cheat sheet. We're going to have study guides that are on Canvas for us to complete. And I will have a printed version that will have different but similar questions, so you guys have lots of practice before the final exam. Also, your final exam in here will be the last day of school. It will be Tuesday the 24th. It will be the first exam you take that day. There are 2 sections to the final exam. There's a multiple choice portion that's on Canvas. You will need to remember to bring a device with you. You cannot complete this on your phone, so you need to bring your computer or your Chromebook with you, along with a charger, so that you have it that day. That's the multiple choice portion. We'll do that first, and then we'll do the portion that's on paper after that. The Canvas portion of it will be timed so that you don't spend too much time on that when it's not worth as many points as the paper portion of the test. So the way I've done this in the past, and it seemed to work out well to students' benefits, if the multiple choice portion of the exam is worth 30% of all the points, then I dedicate 30% of the time for that. So that way you have the most amount of time to spend on the stuff that's worth the most amount of points. Okay? I try to be very fair about it, and like I said, in the past, this has worked out to students' benefits. It helps their grades overall. You can always guess on multiple choice things. You can't guess on the written portion. Also, last but not least, all of your homework has to be turned in by this Friday. Any and all Canvas assignments will close on Friday. The stuff that we're using for final exam review notwithstanding, but anything up through Unit 12, including the descriptive statistics homework, will close this Friday. So please make sure, if there's anything that you still have sitting out that you've been thinking about, I really need to get on that and do that, please make sure it's done by Friday. All right. That's everything from me.